Okay, we've posed the question. By what factors can we geometrically extend a line segment? Of course, we can also divide a line segment. We've already divided it into half, which means we change its length by a factor of 0.5 by 50%, or by 1/2. 3/2, that would be your 150%, the 50% increase. 5/4 would be a 25% increase. Here would be a 75% increase. Here would be a 125% increase. And of course, the 75% increase would be you increase by factor 7/4. Okay, you have the line segment. You increase it by 75%. Well, that'd be an increase of 3/4 over the full length that you already had, and so forth. So I believe that what we saw previously, if you don't understand what I just said, if you look at it again, you will. Of course, we can extend lines by a factor of 2, 3, 4, just set the compass in the original length and then make as many of those as you want. So that's always possible. What else is possible? Okay, well, just think about it. We can divide the length and change the length. And actually, this whole term divide or extend, I'm gonna actually right here in front of your very eyes change my language just a little bit, and I'm gonna say, instead of divide or extend, that language is starting to get a little bit confusing. I'm going to say change the length of. Okay, so let's see if I can write that. I have to let it dry for a minute, but that's going to read change the length of a given line segment. So we can change the length of line segment by factor 1/2, meaning it's going to become 1/2 as long. By factor 3/2, meaning it's going to become 3/2 as long, or 50% longer. Now, we can change a length by factor 1/2, of course, and we've already written that. We didn't write 1/4, but we saw that we can do that just by bisecting it to get 1/2, and then bisecting half of that to get 1/4. Well, what other fractions immediately follow from these? Well, we could get, if we bisect the 1/4, what do we get? And you should stop and think about that to make sure you see what it should be. And I'm going to say now, and I hope you stopped and got your own opinion, but it'd be 1/8, because we cut 1/4 in half, we have 1/8. And then we got 1/16, and so forth. Okay? Now let me come back here and make that say change the length of a line segment. Okay? So we have all these possible fractions. So with this as a basis, I'm going to pose the question of what other fractions are possible. Okay, what can you build based on the fractions that we've seen? What fractions can you get if you know that we can get all these, and are there others? Okay, so the question here now is, can you show how to build a list of all possible factors? Now there's a related question. Could you get a factor of 1/3? Okay, so can we trisect a line segment? Can we cut a line segment geometrically, by geometric construction? And I don't know why the camera wanted to go out of focus there, but let's see if we can bring it back. Come on, I'm still fuzzy. Okay, there we are. Can we trisect a line segment? Now, I don't know which camera did that. Actually, I do. Okay, can we trisect a line segment? Can we cut it into 3 equal pieces? And I'll tell you right now that unless you know the answer to the question, you're not going to be able to figure it out. Okay? In real graduate school mathematics, I'm not talking about the kind of graduate school mathematics you get from an online university where you simply buy a graduate degree, but the kind of degree that you get if you're offered graduate school support by an institution. And I'm not talking about need-based financial aid. I'm talking about the kind of support you get when you become, say, a graduate teaching assistant and you're given courses at the university to teach in a real research institution where we're talking mathematics research, not something like mathematics education research, which can be a very valid field, and I'm not knocking that field. And we have a lot of great people in these fields, but we're talking pure mathematics research, even applied mathematics research. I mean, there's pure and applied as kind of a boundary line. I'm emphasizing that. And we're talking about an institution where you start with calculus as an undergraduate in your freshman year because there's nothing offered at that institution under calculus. Okay, if you're not ready to do a rigorous calculus course, you don't do it. You can't be in that institution. So you start with a rigorous calculus course in your freshman year, and every year for 7 years you build on it. If you're in that kind of a institution where everything builds on everything else, you will somewhere in the 4th or 5th year, unless you're really a genius and able to accelerate your pace. But generally, even for somebody that caliber, no earlier than the 3rd year. You would, I don't know what's going on here. This camera keeps going out of focus. Okay, and this video you're looking at might be from the other camera. Anyhow, I've got to put something here for it to focus on for a few minutes. Okay. You will begin to develop the mathematics that allows you to answer this question. Okay? It's far, far beyond something that a typical high school teacher, although there are many high school teachers who've gone that far, or a typical even two-year college instructor will have been able to do. Okay, it's very deep, and this question occupied the best minds in mathematics, many of the best minds in mathematics for over 2,000 years, and it wasn't solved until Ernest Galois came along. So the Galois theory. So if you want to know why we can't trisect a line segment, come back to me in about 8 years, and if I'm still able to explain it, I'll do that for you. Okay, so, no. Answer is no. Okay? Then we notice that the denominators of all these fractions are powers of 2. Can we divide a line segment into some subdivision, maybe not 3, maybe 5 or 7 or 6 or whatever? Is that possible? So what about a factor other than one whose denominator is a power of 2? And the answer, I'm 99.9% sure, is no. I'd have to work out the field extension and the whole Galois theory to make myself really confident of that answer. Of course, I could look it up, but that's no fun. Okay, but I'm going to say no. If I'm wrong, come back someday and prove it. Okay, and I could be. I'm 100% sure of this, not 100% sure of this, but really 99-point-some% sure. Okay, so the question then is, and actually I just lied. There are other factors. Okay, now I've made it true. A rational factor other than those whose denominators is power of 2. Okay, what about pi? Okay, pi is not a rational factor, so that hasn't been addressed. Okay, well, set of interesting questions, but start by building a list of these factors.